Hello guys, welcome to i-tutor Academy. In today's session, we will start with Unit 6, subsection 5, some important discrete probability distributions. So let's begin with that. While examining the different ways of assessing PMF, that is probability distribution, we have noted that the proper identification of experiments with a certain known process in probability theory help us in writing down the probability distribution function. Two such a processes are the Bernoulli and the Poisson. The standard discrete probability distribution that are consequent to this process are the binomial and Poisson distribution. The objective of this final section is to look into the conditions that characterize this process and examine the standard distribution associated with the process. This will enable us to identify situation for such these distributions apply. Bernoulli process. Any uncertain situation or experiment that is marked by the following three properties is known as Bernoulli process. There are only two mutual, exclusive and collectively exhaustive outcome in the experiment. In repeated observation of the experiment, the probability of occurrence of these events remain constant. The observations are independent of one another. Typical example of Bernoulli process are coin tossing and success failure situations. Okay. These are the examples of this Bernoulli process. And the random variable that may be of interest in the above situation are the number of success or failure in a specified number of trials given the knowledge on the probability of a success in trial. This implies that if the experiment is observed and times when given that the probability of a success is same for any observation, we are interested in finding out the distribution of number of successes that may occur in an observation. The number of trials needed to have a specified number of successes given the knowledge on the probability of success in any trial. We are interested in finding out the probability distribution of the number of trials required to get a specified number of successes. The binomial distribution and the Pascal distribution provide us with the required PMFs in the above two cases. And two distributions with the example is here. Binomial distribution, let us take the example of a machining process which produce on an average 80% good pieces. We are interested in finding out the PMF of the number of good pieces in the 5 unit produces from this process. From our definition, this situation is a Bernoulli process with the probability of success. And here is an example also, and this is based on the equation. Here is that. And Pascal distribution, suppose we are interested in finding the PMF of the number of trials now n required to get 5 successes given the probability p of success in any trial, that is Pascal distribution. And here is example also. And Poisson process and Poisson distribution is here. Condition specific the two Poisson process are easily seen by establishing them in the context of Bernoulli process. Okay, so here is equation based examples are explained here. You just go through your IGNOU study material, it will more clear. Okay, the above function in a position PMF, thus the Poisson process correspond to a Bernoulli process with a very large number of trials, clause n, that is number of trials represented as n, and with a very low probability of success in any trial. Consider the occurrence of any uncertain event over time or space in such a way that the average occurrence of the event over time or space in is m. Okay, that is minute. The equation is that. And activity also based on the same. Activity E, activity F are here. You just try to, and activity G also here, and you just try to do the activity. It will more clear for you. In between any doubts you can contact us. And a summary of this Unit 6 MMPC005 is here. We have introduced the concept of random variable and probability distribution in this unit. In any uncertain situation, we are often interested in the behavior of certain quantities that take different values in different outcome of the experiment. These quantities are called random variable, and a representation that specifies the possible value a random variable can take together with the associated probabilities is called a probability probability distribution. The distribution of a discrete variable is called a discrete probability distribution, and the function that specifies a discrete distribution is called a probability mass function. Probability that mass function is short for PMF. And we have looked into situation that give us rise to discrete probability distribution and discuss how this distribution are helpful in decision making, the concept and application of expected value and other summary measures for such a distribution have been presented. Different methods for assessing such distributions have also been discussed. In the final section, certain standard discrete probability distributions and their application have been discussed. And here is further reading section also. Here there is no related questions are there, section based activity is there, so it's probability based, so you just try to answer that. It will help you for your term and examination. And for more IGNOU MBA videos, you just do like, share and subscribe our channel. Thank you so much for your support.
i-tutor Academy presents IGNOU MBA complete syllabus coverage classes for individual students, semester-wise subject with online and flexible timing. For more details, contact on +916 238 21785.